Hello, today we're going to look at the area of a right-angled triangle. Here is my right-angled triangle. I drew it in this way with a right angle, of course. Now, a triangle has three sides, and the side opposite, directly opposite the right angle, is called the hypotenuse. It is the longest side of a right-angled triangle. This is always true for every right angle triangle. So the opposite side to this right angle, this is the hypotenuse. And I label the other two sides A and B. Then I flip the right angle triangle. This is exactly the same triangle. I just flipped it. So you notice now that my B is here and my A is here. The hypotenuse obviously is still the hypotenuse, the side that is opposite the right angle. Now you would look at the area of the right triangle, and that is half times A times B, or A times B divided by 2. More commonly, people always say that it's base times height divided by 2, or half base times height. Then I have come across students who are very afraid of flipping the right triangle, because it seems that over here A is the base and B is the height, but when you flip it, B is the base and A is the height. So which is the base and which is the height? Well, the fact is, when you are applying the area of a triangle formula, the right triangle, it really doesn't matter, because half times A times B is the same as half times B times A. As long as you multiply the two sides, these two sides, that is not the hypotenuse, the other two sides, just multiply these two sides together and divide it by 2. You will get the area of the triangle, the right angled triangle. So again, the side that is opposite this right angle, the longest side of the triangle, this is the hypotenuse. And when you are applying the formula to find an area of a triangle, you do not actually touch that side. You take A times B. And whether it's A times B or B times A, this can be A and this can be B, the answer will be the same. Now, the thing to note for grade 6 students is that if you have a triangle that is not a right angled triangle and you need to find the area of, for example, triangle ABC, you need to partition this triangle into two right angles. In this example, I dropped a vertex. I dropped a perpendicular from the vertex A down to the floor, making a right angle with the floor, intersecting the floor at point D. AD is the height of the right angled triangle ADC, and it is also the height of the right angled triangle ADB. There are two right angled triangles in this diagram, and they make up triangle ABC. I have partitioned this ABC triangle into two right angled triangles by drawing a perpendicular from the vertex A to the floor of triangle ABC. So here I'm just explaining what I did, right? So I say that in ADB, this triangle here, AD is the height and the base is BD. It's not BC, it's BD, because we're now talking about just this portion of the triangle ABC. So for the right side, the right triangle like ADC, the height is AD and the base is DC. So you find the area of these two right angled triangles and add them up to make the area of triangle ABC. In future, if you go on to secondary 3 and secondary 4, you will learn a new formula that will enable you to find the area of triangle ABC straight away without having to divide it into right angle triangles. But for now, you have to do this. So this is the end of my presentation. Thank you for watching.